Okay, so now we have example number 1. We have y squared equals negative 8x. First, we need to identify the opening of the graph. The graph opens to the left. Y to the left. If it's in the form y squared equals negative 4cx, that would mean it opens to the left. Okay, now what about the vertex? The vertex is at the origin 0, 0. Why? We follow the form. If it's in the simpler form, we have y. We can see any k in here, and then we have x. Then we can see any h in here. That means it's 0, 0. So it's at the origin 0, 0. Then the next thing to do is compute for c. Okay, how do we compute for c? Remember, I've mentioned that its form is actually y squared equals positive or negative 4cx. Positive for those which opens to the right and negative for those which opens to the left. Now, how do we compute for 4c? Simply equate. We have here negative 8. So we know that negative 4c is equal to negative 8 on this given equation. And then simplify, divide both sides by negative 4. So cancel. Negative 8 divided by negative 4 is positive 2. So we have c equals 2, negative divided by negative is positive. We already have the vertex, the value of c, and its opening, which is to the left. Okay, let's now proceed with the equation of the directrix line, which is defined as x equals h plus c. Now we already have h and k from the vertex. H is equal to 0, and we have computed for the value of c, which is 2. So we write here x is equal to 0 plus 2. And then simplify. That would mean the directrix line is x equals 2. Okay, this time let's have the equation of the axis of symmetry. We have y equals k, and again k is equal to 0. So we write here y is equal to 0. For the focus, we have here focus is point F, h minus c for the x coordinates, and then k for the y coordinates. So just substitute. H is 0, and then c is 2. 0 minus 2, and then k is also 0. So simplify. For the focal point or focus, we have 0 minus 2, that is negative 2, and then 0. Okay, lastly, we'll have to find the coordinates of the endpoints of the latus rectum. We have LR sub 1 and LR sub 2. Going back to the figure, now we have an idea of how the graph will look like. It opens to the left, the vertex at 0, 0. And then we have the latus rectum like this one. So for example, the latus rectum is this segment or line segment. That means to say it will not be moving in terms of x. That's why if you can see, the formula are both h minus c for the x coordinates. But we will be adjusting on the y coordinate because one is located here, down here, and then the other is located up there. Okay, so let's substitute. We have h is 0 minus c, that's 2. K is also 0. Minus 2c is 2 times 2. Okay, and then simplify. 0 minus 2 is negative 2. And 0 minus 2 times 2. Simplify 2 times 2, that is 4. 0 minus 4 is negative 4. So LR sub 1 is at negative 2, negative 4. That is on the third quadrant. Okay, now for LR sub 2, the other endpoint of the latus rectum, we have h minus c again. 0 minus 2. Actually, you don't have to solve because we already have that here. That's negative 2. And then k is 0 plus 2 times 2. That is 4. So this time we have negative 2 and positive 4. So this is your LR sub 2. Okay, let's now plot the points on the Cartesian coordinate plane. So let's start with the vertex at 0, 0. Okay, let's name it as point V. And then we have the focus at -2, 0. So 1, 2, let's say we have here -2. So let's name that as point F. And then we have LR sub 1 at -2, -4. So again, this is -2. And let's say this is -4. So this is LR sub 1. Then we also have LR sub 2 at -2, +4. So 1, 2. Let's see, this is 4. Okay, so let's name this as LR sub 2. And then once we already have the points, we may now connect those points. So this is from LR sub 2, connecting a smooth curve to the vertex. Of course, not including the focus because that's inside the curve. And then going to the other endpoint of the latus rectum. So as you notice, the latus rectum serves as our guide in making the curve of the parabola. The axis of symmetry, if you want to present the axis of symmetry, that is y equals 0 or the x-axis. So this is the axis of symmetry. Okay, so that's the axis of symmetry, the x-axis. And then lastly, we have the directrix x equals 2. That will be outside the curve. So +2 is on this side. Just draw a straight line, not like this one. Straight line. Okay, imagine that's a straight line. So we'll have x equals 2. And we are done. Now we have a better version of the graph of the given parabola with the equation y² equals -8x.